Hi there, I'm Luke Davidson. I'm the founder of Bundy Grow. We distribute Eclonia maxima Kelp Seaweed cold pressed as a biostimulant around the world, particularly in Europe. I'm giving a presentation on the various properties in agriculture and the mode of action and some of the trial data. So I hope you enjoy. Come to those fishermen. This is what it looks like, and so this is the Eclonia maxima. We are harvesters of just the top end here, which is the blades that we're looking for. These blades, by the way, can grow up to 6 meters long, so it's quite phenomenal. This is where all the photosynthesis happens. So this is where all the energy lies, the amino acids and the sugars. The stripe, which is like the stem on a normal plant, this is very flexible, quite hard, quite leathery, and contains a lot of alginate. So for companies that are looking to source alginate, most of the alginate, or more, proportionately more of the alginate, is in the holdfast and the stripe. The holdfast, which is kind of like the root, has a completely different functionality to terrestrial plants because it doesn't function as a nutrient absorber at all. The only function of holdfast is to hold fast onto a rock or onto the substrate of the ocean surface or floor. So all the absorption happens through osmosis into the plant. This, yeah, like I've identified there, the Eclonia maxima can grow up to 0.5 meter per day. Generally speaking, on average, it's growing about 10 centimeters per day. The way that it works with our harvesting policy in South Africa is if you are just harvesting the blades, then you're able to harvest every 6 months per block. If you're harvesting the entire plant, you can only harvest once every 5 years. Okay, so in terms of the attributes of the plant, it has been sort of the narrative a while ago, quite some time ago, was the thought that because it grows so fast, it's going to be full of growth hormones, and that's the reason why it's stimulating so much growth in our crops. But that doesn't seem to be the case. That's been disproven through numerous studies, and it's seemingly that the polysaccharides have a greater contribution to the general stimulation of root systems and plant health. So polysaccharides, they enhance the root development, and they improve the soil structures. Water holding capacity, that's also really important. Polysaccharides have water holding capacity, which helps in retaining moisture around the plant roots. This is particularly beneficial during dry periods as it reduces water stress and increases the plant's ability to withstand drought. What you'll notice also later on when I'll go through some of the studies, there is the greatest difference or benefit when plants are under stress, and the polysaccharides have a lot to do with that. They also have a wonderful chelating ability, so allowing for all the nutrients that are in your soils to become available. It's because the polysaccharides have that chelating ability, and chelating means it comes from chlor, and it basically holds and makes those nutrients and surrounds the nutrients, makes the nutrients really available for the root system. Yeah, like I alluded to as well, the stress tolerance, polysaccharides act as a stress protectant, and that helps with all sorts of stresses like drought, salinity, and extreme temperatures. It's because the The polysaccharides, they create like a protective barrier around the plant cells. Right, now betaines, this is a wonderful attribute, and I think this, along with what I'll talk about in a second, sterols, these two have been proven to benefit tremendously in terms of um, the ability for a cell to hold on to its own water under stress. So betaines fill the inside of the cells, and they help with all sorts of metabolic processes within the plant. It can enhance the production of important compounds. Its main function, though, would be the osmotic regulation. Betaines act as an osmoprotectant, helping plants cope with environmental stresses. And they help to maintain cell wall balance, preventing cellular dehydration and damage. So we see drought, especially, or periods of just lack of rain. This is where kelp can be hugely beneficial. So when we see it a lot, particularly in sports turf. If you can imagine, turf is that's a sector I'm quite involved with. In fact, Ukelp, I think, is the predominant product used in the Premier League in the football clubs in the UK, and I'm based in the Netherlands, so it's all the same here. Its turf is under tremendous stress, as you can imagine. The grass is being cut 3 to 5 mil, if it's lucky, 5 mil on the greens. So tremendous stress. And it's not able to photosynthesize, so not getting the energy that it needs. It needs to be rooted well, which is obviously quite a struggle for the plant. It's under a lot of compaction with all the feet walking on top of it. So these stresses are tremendous. And then, of course, you've got the abiotic stresses, so environmental stresses like lack of water. So during the sunny periods when everyone wants to golf, there's no water. So there's, again, those stresses. We see tremendous differences in the health of plants when using kelp at as little as 5 liters per hectare. So, yeah, really, really helpful. Betaines, like I'm saying, these are compounds that go inside the cells, and they're able to hold that water inside the cells. Sterols, are kind of like fatty substances. They've got lipids, and the idea with sterols is they help with the elasticity of the cell walls. So if you think betaines are helping internally in the cell, you've got the sterols, which are helping with the structure of the cell itself and helping with that elasticity, helping again with to assist with osmosis and keeping what's needed to stay within the cells, keeping it within the cell, especially under times of hydration. And then we have the growth hormones. So there are growth hormones inside of Eclonia maxima, and Ascophyllum nodosum, Eclonia maxima. It doesn't really matter which kelp, they're filled with these growth hormones, but only at really small quantities. We used to think that they actually contributed to the growth hormone content of the plant, but that doesn't seem to be the case. It seems that what kelp does is stimulate the synthesis of growth hormones within the plant. So it doesn't seem to be that the actual content of auxins and cytokinins that are within the kelp are the contributing factor to growth, but it's actually the stimulation of growth within the plant, the synthesis of growth in the plant of these auxins and cytokinins. Now, auxins are responsible for the elongation of the cells. Cytokinins, cytokinesis, they're chopping those cells in half. So you get an elongation and then a chop. So where you are applying this, the biostimulant if you're applying it as a folio feed, you're going to get more vegetation. If you've applied it as a root drainage, you're going to get better root growth. Sugar alcohols and osmoprotectants. Again, we're talking about osmoprotectants, and the reason why I put this slide on particularly was because of mannitol. We're getting a lot of research done about this. There's a lot of white papers written about the contents of mannitol. Osmoprotectants like mannitol help maintain the osmotic balance inside plant cells when they are exposed to stresses that can disrupt balance, such as drought or salinity. By maintaining this balance, osmoprotectants help keep the plant cells functioning normally under stress conditions. So, yeah, mannitol, that's a bit of a buzzword in the kelp sector at the moment. Amino acids. So these are the building blocks, right? Come from proteins in that family, and amino acids in kelp. In the Clonia maxima, we get the full spectrum, and we've got 17/18, the additional amino acids. So it's basically all of the amino acids we have. I'm not going to go through the benefit of everyone, but basically, you get nitrogen metabolism with these enzymes. The ones that I've highlighted are methionine, which is it's the precursor to ethylene and other growth-related compounds. So that's your hormones that I spoke of earlier. And then the tryptophan, which is a precursor to auxins as well. So again, these amino acids are what we understand now to synthesize growth hormones, and that's why we're getting such increased vegetative growth and root growth. With the non-essential amino acids, proline often accumulates in the plants under stress conditions. Proline can help protect plants from damage due to drought, salinity, and freezing, and heavy metal toxicity. That's a very important and non-essential amino acid. And then we have the one that I'm also highlighting there is arginine, which plays a vital role in nitrogen storage. The other two that I haven't highlighted but are also very important is glycine and glutamic acid, because they aid tremendously in the uptake of calcium. Calcium, very important for the general building block and strengthening of the plant. It's essential for a really good vascular system in the plant. And that's come up numerous times in studies that kelp has no calcium really in it, very, very, very small amounts. So it's, but when you have calcium available in your soils, it's glycine and glutamic acid that will help tremendously in the uptake of that calcium. So again, it's just reiterating what's happening with the use of kelp is that you're getting far better water uptake and nutrient uptake, and you're getting the stimulation of growth in root and vegetation. So those are the highlighted four that we often look for. If we're looking at a biostimulant, at a kelp, then we will, from the analysis, we'll typically look at those four, but also it would be important to do the glycine as well and glutamic acid. If we can see that they have high numbers of these amino acids, then it's going to be a good extract. This is the amino acid structure of Ukelp, our product, and as you can see, we've got all the amino acids, the full spectrum available. Right, so with kelp, we have this is just to give you an idea of how different species vary. The numbers that we have here, everything accumulates to 100%, and we're just saying the percentage of non-essential amino acids to essential amino acids. If you look at 27 and 73 equals 100, right? So everything's adding up to 100, but you're just looking at the seesaw balance between the two, and some are higher in non-essential and some are higher in essential. So depending on what you're looking for, you can actually choose the extract which is more suitable for your needs. The ones we come up with, just to let you know, the ones that I come up with predominantly in the industry is Ascophyllum nodosum. We're Ecklonia maxima. I think Ascophyllum nodosum in Europe particularly has a really big market share, and they're doing wonderful things. Antioxidants. This is really important. As under stress, you get oxidation that occurs, and you need these antioxidants to be available in the plant. They pass through, if you're feeding them as a foliar feed, they'll pass through that waxy cuticle area on the leaf, pass through as a foliar absorption. They go through translocation within the plant, and then in the vascular system, can interact between each plant cells. And they're just basically neutralizing that oxidative stress, particularly when the plant is in drought conditions. So the macronutrients, it's not particularly high in macronutrients. Phosphorus is probably its highest content. It doesn't contain calcium, but like I said earlier, it contributes massively to the uptake of calcium. And then its micronutrients value, it does have this full spectrum. And with micronutrients, you need tremendously small amounts. And that's why these micronutrients can catalyze thousands of reactions per second. So with just, one element. If I just quickly pause and see, I'm half an hour in. I just want to hear from you how you're doing. Is there any questions? I'm just looking at the chat. I haven't got a chat at the moment. Anything that is everything clear so far? So let's give a thumbs up. Thumbs up. Okay, we're doing good. Okay, just drop a question if you do, just a reminder. I see here talking about helping with acid soil. Is it helping by reducing hydrogen atom from carbon acid? So acid soils, I would say it's not a buffer. You'd need to look at something else with acid soils. In fact, Ecklonia maxima and most of the good quality seaweed extracts will be quite acidic. Ours is about 3.5%. Irrigation spread. Okay, these are quite particular, specific questions. Thanks, guys, for sending them through, and I do appreciate them. I'm going to keep them, but I think these kind of questions, because they're so specific to your needs, either we need to have a one-on-one meeting, which I'm very, very happy to do. I think I'd like to schedule with as many of you as possible, so one-on-one meetings. But I think that'll be more appropriate than for now. Okay, let me kick into this forms of extraction. Very important when evaluating your product. If you're looking at a biostimulant, you want to ask the guy, because this is the biggest contributing factor to the benefit it will make to your crop. You want to ask them, was it done enzymatically? So the downside to enzymatic extraction is that they use alkaline and acidic solutions. And with that, there's a breakdown of a lot of the compounds. Same with fermentation. Fermentation requires a lot of heat. And in the heating process, you're going to destroy a lot of the growth hormones and enzyme. Enzyme are like keys that stimulate reactions. And because if you think of a key, the heat will expand that enzyme to the point where the shape changes and it can no longer function as an enzyme, or function as it's supposed to catalyze those reactions. So when you ferment, you do lose a lot of that enzymatic ability, which is really important, what you want to keep. Cold cell bursting is what we do, and in our opinion, but I think it's more than just an opinion, it's basically we're extracting all the juices, the liquids from the kelp seaweed. We don't do any dilution other than the minimal amount that we need throughout this flow process. We calculate roughly around 8% water is introduced throughout the entire process. And we keep that to a minimum, but we do need it. For instance, the press needs to be lined with water in this first stage here. When you're chopping it up into smaller pieces, you do need a little bit of water. So it's in those times that we keep it to a minimum. And then micronization is also really good. It can be really good for soil drenching, but again, you're losing some of the liquids, but the fibers indeed are quite fantastic. So also good, but you are losing some of that nutrient capacity. And remember, kelp is 85% liquid, so it's the liquid that you really want. That's where the sugars and all the amino acids are. Okay, so like I was saying, for a biostimulant, the brown algae are the best. They have the highest value of NPK, and they just have the highest value of sugars in general. So if you're looking for proteins, nutrients, amino acids, it's the brown algae to go for. But there are a lot of benefits to the others as well. You'll see with the red algae, they're used a lot in cosmetics. And the blue-green algae also with pharmaceuticals. So there's just in our sector, it's the brown algae that we're focusing on for agriculture. It's a sector that's growing all the time. This just gives you an idea of the monetary value to the industry. This is our little sector here. You can see it's probably one of the lowest numbers, but Econia maxima is only really grown in the South African part on the west coast over here. There's been a wonderful meta-analysis. It's the first of its kind. I don't know of many meta-analyses out there, so if anyone does actually that's listening here, please send them through to me. I'd love to check them out. But the one that has been done earlier this year, I think it was in March, if I'm not mistaken, over 180 qualified studies, over 1,000 trials, and the average benefit to crop yield was 17.9%. If you can imagine, you're applying between, on average, 2 to 3 liters per hectare per application. Most of the time, they're putting down between 3 and 6 applications. So you're spending between $20 and $40 per hectare for a season, and you're getting a almost 20% increase in crop yield. This is phenomenal return on investment. And to think that this is a natural product that requires no inputs whatsoever in the farming of it. It's just sequestering carbon dioxide. It's really a dream product, and a product that should be supported. I imagine once this is well known and well documented, it's going to be on the portfolio of every single agricultural farmer out there because of its return on investment capacity. This is just looking at the difference between synthetic auxins, so synthetic growth hormones, versus using a kelp seaweed. And this is actually an internal trial that we did, and we saw quite a big difference with the tomatoes, and then a slight difference with the vegetables. But that's just to give you an idea. There are synthetic growth hormones out there. In fact, what some manufacturers are doing are introducing synthetic growth hormones into the extracts. I'm not a fan of that idea because it has been disproven that they contribute any further. And as you can see in this trial, there's absolutely no benefit to add them. Okay, so I'm going to go through just a couple of the trials here that we've done. And what you'll notice is a common thread with all of them is that there's an optimal amount that we see a benefit with. So we have to go through all these crops, and we have done crop specific one by one to understand what is that optimal amount that's required. Because like you see over here, when using, so this is 1 liter per 100 liter of application water, where you would use, say, 500 liters per hectare. So this is at a 5 liter per hectare rate, and then we're doubling it here. So that would be 10 liters. And as soon as you go to 10 liters, it's going to be almost the same as the control. Now, a lot of farmers experience so we give them the application rate, which is on the TDS, right? And so they'll see the first season, they'll go, oh my goodness, we've just doubled, or more than doubled in this case, our crop size. And I'll just hang on 2 seconds. I see my charger has just dropped out. There we go. Dropped completely. And then, of course, yeah, so the farmers will go like, hey, we just doubled our crop size with this small introduction of kelp. Can we do this again? And then they'll double it again, and then they see this. Now this, as we go through them here, we see the same here. This is in citrus. So in South Africa, there's a lot of citrus farming. In the Netherlands and the UK, a lot of the fruit comes from South Africa. And here we found the same thing. We get 1.5. There's a lovely increase. You get to 3 liters per hectare. Wonderful increase. Go beyond that up to 6 liters, and suddenly you get that drop again. Baby marrows, again, 50 mil to 10 liters. And there, where we've doubled it, it's actually gone below the control. This, we've done this with green beans, but this goes across the board. It's really, it doesn't matter what crop you're harvesting. Under drought conditions, you can expect the same response. So when your soil is really optimal and the conditions are optimal, then you see just a very small difference in your yield. But if there's any drought conditions with as little as you saw earlier, 3 liters per hectare, you're seeing 25% difference in most cases. And that's because the sterols, the betaines, the polysaccharides, all those protective attributes. When you've got a soil that's depleted of nutrients, all you need is a very small amount of trace elements, where these little guys and compounds and proteins and polysaccharides to kind of just help that plant hold the water that it has, hold the nutrients in, give it the ability to absorb the little water that's available and the nutrients that are available, and it makes just a tremendous difference. Here we go again. Here's some with apples, 3 liters, optimal, 6 liters, same as control. Here, this is the label, and as you can see here, we've got all our crop types, and we just highlighted the optimal rates. It's also certified for organic farming, so it fits perfectly in with your green program. Okay, and then I'm just going to quickly go over, Ukelp is wonderful. As a biostimulant, seaweed is a wonderful product, but it should be used in combination with a number of other products. We use this threefold combination. In fact, there are a number more than just the three, but this is quite a good formulation. The Champion, I'll talk about this a little bit in a follow-up presentation. That's going more into your humic acids, fulvic acids, looking at organic acids like citric acid, then looking at getting a richer and more dense amino acid content from your protein hydrolysates. So when you use this in combination with seaweed, you get just with the protein hydrolysis, you get a higher nitrogen content, so you get a greater feed, and it's a natural feed. The oxyturf and oxyagri for agriculture, that is used to decompact soil, to keep it well aerated, and to stimulate aerobic bacteria. All right. I think I'm going to leave it at that for now, just to go over a couple. These are the kind of products that we also have in our portfolio that I'd love to, talk to you further. If you are interested, please you can get in touch with me. The Gladiator is a monosalicylic acid. This I'll also do another talk on at a later stage. Fantastic element in plant strengthening. And then we have organic wetting agents, which hold water really well and help with spreading the nutrients over the leaf, allowing it to be more absorbable. So that's our portfolio for now. I'm going to just exit this, and I'm going to leave it open for those that would like to ask me any questions. Let me just stop the sharing. Okay, perfect. So what I would like to do, thank you firstly for everyone that's made it through, 45 minutes in. So that's fantastic. Thank you very much. I appreciate your time. If you would like to, I would like to share any further detail with you that's more specific to your needs, your industry, and your crop. There's two predominant sectors, the agricultural sector, and there's a sports turf sector, because I see in the audience here, this is mainly who I'm looking at. If you want any specific answers, if we can tailor some solutions for you, please, that's what I'm here for as well. As much as an educative seminar this is, I'm also here to help wherever I can in supplying with these nutrients. Do we have any questions? Feel free to unmute at this point. I see. Okay, hold on a second. Let me go through. Well, there is actually quite a list here. Let's look at the chat. So, okay, Summit. My irrigation and spraying water got a high EC and contains high sodium. Does Kelp help reduce stress caused by high salinity? It certainly does. That for high salinity, absolutely. I'd also suggest using. There's a product that we have which is rich in enzymes like peroxidase. It provides a lot more oxygen to the soil, and it's a slow release. That in conjunction, when you do have sort of brackish water, really, really helpful to have those two products. In hydroponics, I don't have a lot of material, but we are doing some studies at the moment in hydroponics. But as if you've got a liquid product that you apply at really low doses, and it's providing that liquid source of energy, polysaccharides, everything that I went through. So using it in hydroponics makes complete sense. Again, what you'd want to do, depending on your system, You don't want too much, because what it does in soil is it increases your biofilm, and that's going to get an increased sort of bacterial activity. But in a hydroponic system, if your biofilm gets too dense, then your flow rate starts to make channels in your flow rate. So you want to be mindful of that. And to combat that, I'd also suggest what I spoke of earlier. There's a product called OxyFlow, wonderful for hydroponic systems and irrigation systems, and just making sure that that biofilm layer doesn't get too dense and block up like your dripper systems or create any channels. Really good product to go with it. So when they talk biochemically extracted seaweed, does this affect the quality? It certainly does. So the biochemically, that's what I spoke about earlier. They use high alkalinity, or actually no, sometimes they do use stronger chemicals. You're always going to have cell damage, and there's always going to be some corrosion. So as far as I understand, I would say going to a pure cold pressed is always best, unless they can significantly show you through data. Because I'm not a fan of knocking other products, to be quite honest. I'm really a fan of any company that's investing in seaweed and putting the time and effort to build a company around us, because it really is just such a wonderful area, no matter what you're doing. So what I would do is maybe trial one against the other, but typically speaking, it just makes sense to get it as raw as possible. Since the kelp extracts are probably crude extracts, are there variations in concentrations? So there are. It's not particularly crude. So, our extract isn't particularly viscous. And so its viscosity levels aren't that high, depending on what you're extracting, because you do get more alginate, in that stem part. So if you're getting more from that side, you'll get more viscosity and it'll be more dense. But you can look at a chemical analysis, and that's where you'd be able to tell. Ours is just pure. We try and keep it as pure as possible. There's only that little bit of water that's through the actual pressing procedure. Other than that, it's pure. So the only reason why another company would dilute was to make it more financially viable, maybe, for the customer. So what you could see is in its application rates, it should be, say, 2 liters per hectare, right? But if they say 10 liters per hectare, well, then they've obviously diluted it. That's maybe the best indicator. What are principal polysaccharides that have beneficial effects on water stress tolerance? Well, the polysaccharides, it's basically they're helping the soil structure, right? So that it's those sugars that are filling out in the soil particles. They're helping with aggregation of those soil particles. So it's just the general idea that polysaccharides are going to help with holding water, and also giving better homogeneous flow rates within the soil profile. I see here you've asked what are the principal sterile compounds found in kelp, and is it cetylsterol? That's something I don't have at my fingertips, but I do think I have that detail for you. Give me 2 seconds, I think. Yeah, sorry, that I'll have to get back to you on. I don't have it, and it's going to take me a little bit longer to get that for you. But great question, and I'll answer it. I'll keep that in mind, and I'll send you a personal email on that note to give you the actual cetylsterols. Yes, Ukelp does have organic certification, but it's with the Puya, it's with the OF&G, which is a UK-based certification body, and it's certified for use in organic farming. So Jeremy, one of the lovely things about the use of OxyTurf and Ukelp is that OxyTurf's main function, or its mode of action, they've extracted an enzyme called peroxidase from succulents, and succulents produce their own oxygen. As you can imagine, in these really stressful environments in South Africa, particularly, you've got really high heat, so 40 degrees centigrade, and then it can drop down to -5 in the night in one day. So it's high stress, very, very little water in the desert. So these succulents have to produce their own, hold their own water and keep producing their own oxygen. Otherwise, they erode themselves. So they produce their own oxygen with hydrogen peroxide. It's the same hydrogen peroxide that bleaches our hair gray, right? So, because like the animal kidgin produces hydrogen peroxide naturally. So it produces hydrogen peroxide, but to combat the oxidative stress from hydrogen peroxide, it produces peroxidase. Now, auxins, which has been stimulated through the application of Ukelp, one of the main functions of auxins is the metabolism. One of the main functions of peroxidase is the metabolism of auxins. So when they're used in combination, there's a wonderful step, especially as a soil or as a soil feed. It's wonderful in increasing that root mass, along with all the other attributes of stress relief, because it does have that extra oxygen availability, which is going to stimulate the aerobic biomass, but then it's also it's got just the right amount of oxidative ability to keep a lot of your disease suppressed. I hope that answered that question well enough. And Jeremy, if you want to shoot me a message and I'll give you more detail on that. I've been involved with OxyTurf in sports turf for a number of years now, and it's phenomenal. It's really, really a wonderful product in combination with Ukelp. Okay, thank you for the presentation. Thanks, Moman. And Janita, thanks for your compliments. That's really lovely of you. Andrea, interesting biosim. Does it have also a biocontrol effect? So, in these kind of public forums, we can't mention any of its biocontrol ability, simply because we don't want it to be categorized under as a fungicide, for instance. But what it's really doing is it's stimulating the plant's natural defense system. It's not actually attacking fungi directly or bacteria directly. It's just really stimulating the strength of the actual plant. And that's why you see under those stress environments, where drought in particular or high salinity, it's putting all those attributes into the plant that the plant needs to be strong. So it's the same with humans. If we eat really healthy and we stay exercised, then we don't get the flu, but we're not attacking the flu itself, So yeah, it's not a vaccine. It's just going to gym. Right. So thanks, Jared. Appreciate it. Stefan, what might be the reason that more is not better? What happens in the soil? Very good question, Stefan, because my immediate answer would have been more would have been better. I don't have an educated or qualified answer for you on this one. I'm sorry, but I would like to know that myself. It's just the feedback that we've gotten through all of our trials, that we have to find that optimal rate. But let me dig a bit more and I'll see if I can get you an answer, because it's an answer that I would love to know myself. So Stefan, I'll keep you in mind and I'll try and get that answer for you. I'll send it to you personally. Mokitawa, I hope I pronounced, forgive me if I haven't pronounced your name properly, but how do you test pureness of seaweed? I think I answered that earlier. It's very difficult to test the pureness. And I don't want to say there's charlatans out there or anything like that. In fact, 90% of the people, in fact, all the companies that I've ever been in touch with in the seaweed sector have been good guys, so everyone's just got a different way of formulating them. And I think the best way really is to do a chemical analysis and to look at the application rate. So you can chemical analysis and just find one that for instance, you can use ours is public. So you can look at our chemical analysis. Ours is pure, it's not diluted. You could look at ours and then look at theirs. If theirs looks the same or better, then, go for theirs. If they're, and then the application rate's the same thing. If you see it's 5 or 10 liters per hectare, then it's got to be diluted. So that's probably the best way of doing it. Also, sorry, the mode of extraction, very important, because they do make pastes as well. So you can get, well, I didn't actually mention that, but what is done is with micronization, they make a dense paste and they export that paste to a depot, and then that depot would dilute it into a canister with water, or not dilute, but use put the paste in the water and then mix it up, right? So that's one way that I know a couple of companies do it. So you really want to find out how they're actually producing the product. Thanks, Germany. Fantastic. It's really nice to get these compliments. Thanks, guys. I've worked on this for quite some time, so it's nice to get a bit of positive feedback. Do you face any issues in the waste management? Is it 100% biodegradable? 100% biodegradable. And remember, you're using it in such small quantities that it's all utilized, completely used up in the soil. This isn't like a nitrogen source. It's an amino acid source used in very small amounts, and it's not even traceable after 2 weeks because it's all just used up. Super. We'll organize a meeting. Thanks, Dave. Okay, that's it. I think I've gone through all those questions. Thank you very much again for everyone that's been with me. I really, really appreciate it. It's been fantastic to talk to you. I hope you've enjoyed it. And please send me a message. I'd love to have a one-on-one meeting with you. Love to discuss things further and love to help and supply with some seaweed. Okay, I'm going to say goodbye. Thanks very much, everyone. Take care.
Thank you.
Okay, take care. Ciao, ciao.